For this video, we're going to start looking at vertical asymptotes. So I'm going to take two functions, f of x equals 1 over the quantity x minus 1 and f of x equals 1 over the quantity x minus 1 squared. Now for both of these, something bad is happening at 1, because you can tell if you plug in 1, 1 minus 1 is 0, 0 squared is 0, and dividing by 0 is a bad thing. So we're going to look and see how we know exactly that if we have a number that's not 0 over 0, we have an asymptote, because we know if it's 0 over 0, we have a removable discontinuity, but this is clearly not 0 over 0. So I'm going to take two limits for each of these. I'm going to do the limit as x approaches 1, where we're having trouble, from the left of 1 over x minus 1, and I'm going to do it from the right. Okay, to do that, the first thing you do when you take a limit is actually just plug in. So I'm going to take the 1 and plug it in for x. So I'm going to get the same thing for both of these. So it's going to be a 1 over 0. But what you need to understand is that this is actually, because it's a limit, this is a number that's very, 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 very close to 0. So it's actually not 0, but something really, really, really close. So it's infinitesimally small. So if you divide by something really, really, really small, do 1 divided by something really, really small, you get something huge. And an example of that would be, let's say you have 1 over 1/10,000th. When you divide by a fraction, you actually multiply by the reciprocal. So that's the same thing as 1 times 10,000 over 1, which equals 10,000. So if this was 1/1,000,000th, then it's going to be a million. So both of these appear to be getting really, really large as our value gets closer and closer to 1. So in magnitude, they're both huge. The interesting thing is that that doesn't mean that they're huge in the same direction. This could be a positive or negative infinity. This could be a positive or negative infinity, and that's what you need to check. So I'm coming in at 1 from the left-hand side. So here's my 1. And I'm coming in at it like this. So I'm going to pick a number that's to the left of 1 but really close to 1, something easy to work with, to figure out the sign of this 0. So is this a really small positive number or a really small negative number? So a number right to the left of 1 is 0. So 0 minus 1 is negative. So I'm going to put a little negative on the 0. Now notice when I plugged in the 0, I didn't do 0 minus 1 is, oh, that's negative 1, and change this, which would change my limit to a negative 1. I'm just picking a test value to check the sign of this 0. So now I look at it, I know that 1 divided by something small is huge. Well, 1 is a positive number. This is a negative number. That's what that negative is telling me. A positive divided by negative is negative. So as I come in towards 1 from the left-hand side, my graph is going down. So here's my 1. I'm coming in, and it's going to go down. From the right-hand side, I'm going to pick a number that's bigger than 1, say 2. I'll plug it in. It's my test value. 2 minus 1 is a positive number, so I'm going to put a little plus. A positive divided by positive is positive, and I have positive infinity. So I have an asymptote at 1. If I was actually asked the limit as x approaches 1, that limit does not exist because the heights are approaching two different things as you get closer and closer. So this is what that graph looks like, but I'm really just focused around the asymptote. If we look at this graph, it's a little different. So I'm going to do the limit as x approaches 1 from the left, and the limit as x approaches 1 from the right. And in this case, it's 1 over x minus 1 squared. It may look like we're going to get the same thing, but it's just really close to the same thing. So I take the 1 and I plug it in. 1 minus 1 is 0. 0 squared is 0. So it's 1 over 0, 1 over 0. Now I'm going to check the sign of this 0. So it's from the left, so I'm going to plug in 0. 0 minus 1 is negative 1. Squared is positive. So this one is a positive infinity. To the right of 1, 2 minus 1 is 1 squared is positive. So this is also a positive infinity. In fact, anything squared is going to be positive, so I know that this graph looks different as I head towards 0 from both sides. I'm sorry, as I head towards 1 from both sides. My graph will be going up forever. So we have a different looking kind of asymptote. It's approaching it from both sides. So the limit from the left is positive infinity, the limit from the right is positive infinity. If you look at this together, it looks like we could say our limit is infinity. Sometimes they say it's still non-existent, but you could say it's infinity. Okay, so if you're ever asked what kind of discontinuity does some function have, your choices are basically, for purposes of this class, it could be removable, it could be an asymptote. You could have a jump discontinuity, but that would look like a piecewise function. So if you have something like this, f of x equals x squared minus 6x minus 7 over x plus 1, it's obvious that we have a discontinuity at -1 because -1 plus 1 is 0. The question is, what kind of discontinuity? Is it an asymptote or is it a removable discontinuity? Well, we would know it was removable if we could remove it, which would mean we could cancel out the common factor. But there is a faster way. You can actually check f of -1. And I'm going to plug -1 into my function. So I have -1 squared minus 6 times -1 minus 7 over -1 plus 1. I know the denominator is 0. I look at my numerator. This is 1 plus 6 is 7 minus 7 is 0. So plugging in -1, I get 0 over 0, which means that this has a removable discontinuity. I didn't have to factor and check. Now you can. This means that I do have a common factor. So I could say f of x is, we're going to factor it. I even know one of my factors already has to be x plus 1 because it's going to be a common factor. The other factor is going to have to be a minus 7. So you can check it. X squared plus 1x minus 7x gives us the -6x minus 7. So we have a removable discontinuity, and if I check to see the actual height, I could do the limit as x approaches -1, and the height would be -1 minus 7, which would be -8. So I have a removable discontinuity. It has a height of -8, but the simple way to check what kind, just evaluate your expression. This right here tells you that it's removable. This one's slightly different. It says what kind of discontinuity do you have at x equals -1, and again it's clear that there's a discontinuity at -1. I'm just going to plug in f of -1 and see what happens. So I have -1 is squared plus 1 over -1 plus 1. We know the denominator is going to be 0. -1 squared is 1 plus 1 is 2. So what's happening here is we have 2 divided by something really, 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 really small. So the answer is going to be something very, very, very large, and we have an asymptote. It is a vertical asymptote, which basically tells me that this x plus 1 is not going to factor out. In fact, you can't factor x squared plus 1 without getting into imaginary numbers. So we have our vertical asymptote here.